This x squared is allowed to be canceled.
But there's
Not a
nothing to
problem.
cancel it with.
Is that x squared allowed to be canceled? No, because
It's being added.
being
This is
added.
really tilted.
Put it like
Yeah, you should like. Do you want my water bottle?
I'm on my
Space.
third red pen just for that page. Well, the first page was fine. Second page,
There we go.
yeah. And I haven't even gotten to the
And
third page yet.
occasionally,
So.
and tell me if it keeps blinking. Okay. Just
Well,
check
part
occasionally.
of that's because
Thank you.
lots of kid stuff at home, lots of drama and everything like that. So it's not that it took that long, but it took a while. So I'd love to have them tomorrow. I'm not banking on it. I'll do my best. I am working on it, I promise. Morning, everybody. Happy Monday.
Happy
Happy Monday.
I cannot believe it is not Friday yet.
I know. This week is going to be Tuesday.
And we didn't even have school on Monday. Thank you. I feel I can't tell you the number of times I've been like, oh, it's Friday.
It's not Friday.
It's never going to be Friday.
Tomorrow is going to be Friday.
No, it won't. Somehow the world will, and all of a sudden it'll be like Tuesday. And then I'll probably be banging my head against the wall so much that I'll just collapse. And when I wake up,
It'll be Friday.
it'll be Friday. All right, let's see. This is the first day, right?
It is this Thursday.
It's Thursday. Thursday the 15th.
My birthday.
We just tested yesterday.
Yes.
Wow.
Wait, yes.
It only took a day. And you've already used 3 red pens.
That was just yesterday. Does that seem a long time ago to you?
Yes.
Okay. I was feeling bad because I didn't have your tests yet. And I'm like, wait, that was just yesterday. Oh, then I feel much better. Okay. Sorry. Wow. Okay. They're all long days right now. But the good news is, in a few weeks, I don't have to work too hard because I can just give you an exam. And I can just sit.
Yeah, but then we have to do the work.
You guys don't work anyway, so. All right, let's see. Tests aren't done yet, as you know. They are obviously halfway done. I'm done with page 2. Tonight I will, if page 3, good evening. Are you late for today or early for tomorrow?
Yeah. Early for tomorrow.
Wait. Who'd this come from? Miss Williams? Who's it for? How can I tell?
She just gave it to me like that.
Can I get that?
I don't like that.
There's no name, there's no time.
Is there a date?
There is a date.
Oh,
Well, if there's a date, then it's fine.
This tardy absence is excused per
She
nothing.
gave it to me. Talk to her.
When did she give it to you? First hour? How could I tell?
I don't know.
So wait, you're blaming this on me?
No. I said I don't know. I don't do good.
I was going to say you're lucky, but you're not lucky. I trust you, so I'm not concerned about it. I'm just playing. But wow, that was interesting. Anyway, I'm sorry. Huh?
You just like keep stepping out of the camera.
Oh well, I'm always going to do that. I always walk around, but there are 1 or 2 people that missed this morning, and so they may be checking you out
I'm just kidding.
tonight. So anyway, all right. Let's see. Tests we talked about. After this class, we will have 20 days of classes left before finals. 20 days.
How do you
finals work?
How do finals work? I give you a test, you take it. Next question. No, I'm just kidding. you will have 2 finals per day.
Oh, what?
The finals will be Tuesday, Wednesday, Thursday of that last week of school. So let's see, 3rd, 10th, 17th, so 18th, 19th, 20th. Okay. 18th, 19th, 20th will be exam days. On the 18th, which is Tuesday, you'll have your 1st and 2nd hour exams. On Wednesday, you'll have your 3rd and 4th or 5th, whichever class you have, exams. And on Thursday, you'll have your 6th and 7th hour exams. Each exam is an hour and a half, and you are done going home each of those days at 11:15 a.m.
I love how I have my math and my physics exam on the same day.
Well, don't take the math exam that day.
No, I'd rather take the math exam.
We will. We will review in here quite a bit. I will give you reviews for the exams, for the exam. I will start getting that together. You'll probably have it. Probably the 2nd week after we get back. So probably the week, sometime in the week of December 3rd, probably late in the week of December 3rd would be my guess. I'll give you the first review, and then I'll give you the second review the week after. Something like that, I don't know, I gotta figure that out still. But you'll get 2 reviews, please. You'll get an open-ended review, and you'll get a multiple choice review. And the open-ended review, you'll have a lot of time to work on, you can check that stuff out. We'll probably, in here on our 3 review days, I would assume we'll spend more time on the multiple choice review, because the final will be multiple choice. That's my guess.
The whole thing?
Hmm?
The whole thing?
I have to have your grades in first thing in the morning, the day after your exam. So I can't give you something like this test because I would never be able to get it done.
Are the reviews going to be for a grade?
I have no idea what you said. I couldn't hear you.
Are the reviews going to be for a grade or not?
Are they going to be what?
For a grade.
Oh, God, no.
The final?
No. She said, are the reviews going to be for a grade? No.
I was like, the final?
You got a question, too?
I don't think so, no.
But your hand was up. She was first, that's why I went to her.
No.
No? We're good? Okay. Today, what's up here? We've already discussed that.
I got going right.
So we just finished chapter 5. So the obviously logical next chapter to go to is chapter 11. Goes without saying. I mean, 17. Always good way to go. But no, we're going to chapter 11. You know what chapter 11 means, like in the real world?
No.
Bankruptcy.
Oh.
If you file chapter 11, you're filing for bankruptcy.
No.
We're not doing that here.
Oh.
We're not doing that. But we will be. We will be identifying conic sections. Huh? Conic sections.
Oh, I thought that says comic.
Identifying comic books. Since Stan Lee died yesterday.
Oh,
Yesterday.
It wasn't yesterday?
No.
Oh, wait. I thought you took the test like 3 days ago. You took it
I'm
yesterday.
sad that Stanley died.
I didn't even know who he was.
Okay.
You didn't?
He's the dude in the credits of
Well, I
every
know
single
now. I
Marvel movie
looked
that
it up.
always says something hilarious and ridiculous, and I love it.
I messed up my hair.
Yes, you did.
Both of them.
Right on the camera.
I know, that was the point. Okay, can I not brush my computer?
You all get it in.
I'm now worried that there's messed up.
Did you know which formulas are which?
Today we start conic sections. There are 4 types of conic sections that we are going to deal with. First, that you think that you are the most familiar with, is a parabola. Second, that you are familiar with is a circle. After a circle comes an ellipse. My spacing is definitely done on purpose. And the fourth is a hyperbola. A hyperbola. These are the 4 types of conic sections. We're going to talk about where they come from, why they exist, and how to identify them. That is our plan today, in addition to starting to roll on parabolas. So, why the phrase or why the word conic? Where would you guess that came from? Conic.
Iconic.
Con with the IC.
Yeah.
No, we got nothing on the word conic? Not icon.
You can Google it. It's still funky. Okay, I'm very nervous after what it chose to do 2 days ago.
Keep going. I just said not icon. Huh? Cone.
Oh, a cone.
If something comes from a cone,
It is
conic.
conic. Conic.
Okay? And
Like
so,
that.
here it is.
Oh.
The word conic is derived from the word cone.
That looks hard.
Okay?
Oh.
This is called a double cone. And if you were to take a cross section of a double cone, you would get one of these 4 shapes: parabola, circle, ellipse, hyperbola. If you cut it straight across, you would end up with a circle. If instead of going straight across, you angled it a little bit, you would get an ellipse. If you angled it more so it went through the center, you would get a parabola. There we go. And if you made it basically vertical, you'd get a hyperbola. That's what a hyperbola looks like. Okay? So that's where the names come from. That's where the name conic sections come from. That's how we get conic sections. We're not going to spend time really worrying about that, but people say, where did it come from? Well, that's where it came from. Okay? But what we are going to try to figure out is what is this the graph of? Is that a parabola? Is it a circle? Is it an ellipse? Is it a hyperbola? And the answer at this moment to you guys is, I don't know, because you don't know yet. In about 2 minutes you will. Okay? But this is what the first part of your homework assignment tonight is going to look like. The 5-1 part of your assignment will basically be 12 equations like this, and it'll say, what are they? What is this? And to be honest, your 12 questions will probably take you about 2 to 3 minutes. Okay? And here's why. When we talk about identifying conic sections, the only things we are worried about that we pay attention to are the squared terms. The 8x and the 3y and the 52 are irrelevant in determining what the conic section is. Okay? So, here are your rules. I'm going to put them down up here. It is a parabola if it has one squared term. Is this a parabola?
No.
No, because it has two squared terms. Parabola is the easiest one to identify. If there's one squared term, it's a parabola, done, move on. Okay? I'm going to jump all the way to the bottom to hyperbola next. Okay? It is a hyperbola if there are two squared terms, and those squared terms have different signs. Okay? That makes it a hyperbola. If the two squared terms if there are two squared terms and those two squared terms have different signs. A circle will also have two squared terms. But those two squared terms will have the same signs, and those two squared terms will have the same coefficients. Two squared terms, same signs, same coefficients. And finally, an ellipse, you could probably figure this out working your way down, but it will have two squared terms. You want to continue from there? Same signs.
Different coefficients.
And different coefficients. And that's how you identify. So, Jake, what is this? This is a hyperbola. He says it's a hyperbola. How do you feel about that? You agree? Me too. Why? There are two squared terms, and the signs are different. The x squared is positive, and the y squared is negative. Done. That's it. It's a hyperbola. You see how I'm saying that the 12 problems, God bless you, the 12 problems that you have tonight could take you, on this part, could take you about 2 minutes. Okay? They should be very easy to identify.
So like, will we ever get something that has more than two squared terms?
Well, parabolas, circles, ellipses, and hyperbolas are all two-dimensional. And a two-dimensional graph will have two variables. Two variables, two dimensions. If we got three variables, then that would imply 3 dimensions, and now we're talking a totally different, we're talking another course. We're talking a higher level college course. It's called 3-variable junk.
Stuff you don't want to teach.
It's about that. Huh? Math in space.
4
Sounds
dimensions. 5 dimensions.
Questions there?
27 dimensions.
We are done with 11.1. Okay?
What?
If you see on your calendar, today we are doing 11.1 and 11.2a. Yeah, please, come on. We just got started. The bell didn't even ring at first thingamajigger, which I thought was supposed to be 20 minutes in. Oh, this one is 20 minutes in. Okay. But I heard one yesterday. It was only like 15 minutes in. It was? Yeah, I know, but I still thought it was 20 minutes because nobody tells me anything. That doesn't make sense that they would change it because...
Yeah, because you're still 20 minutes late.
Yeah, because that's the difference between tardy and absent. Uh-oh.
20 minutes.
Yeah. Yeah, if you come in 18 minutes late, you're marked tardy. If you come in 22 minutes late, you're marked absent. And there are some people that try to take advantage of that, which doesn't make any sense to me, but what do I know? All right, so let's talk about our first conic section. What we're going to do is, by the way, you already know circles, correct?
Yeah.
We learned them earlier. Tell me, can you tell me the equation of a circle?
X minus H squared.
x minus h squared plus y minus k squared equals r squared. Well done. Yeah, remember that? Okay. We might touch on that at some point for probably about 5 minutes. But besides that, we know circles. I mean, what do you have to know about a circle?
Round.
Radius and
Diameter or radius.
Circumference.
Center.
center. You need to know center and radius. And if you know center and radius, then you know everything there is to know about a circle. So because a circle doesn't have much to it, and we've already taken care of it, we're going to spend our time on the other 3 conic sections. We're going to spend 2 days on each one. We'll spend today and tomorrow on parabolas. We'll spend Monday and Tuesday on ellipses. We'll spend Wednesday and the following Monday on hyperbolas. Okay? There is going to be a lot of information over the next week and a half. Each of these conic sections has a lot of information. I would suggest as you take your notes that you totally and completely separate each of them. Okay? I might even have a formula section for each, and then an example section for each, or something like that. But be very neat with your notes, because, like I said, there's going to be a lot of stuff, and I'm going to tell you what's going to happen. We're going to go through parabolas today and tomorrow. We're going to get done with tomorrow, and you're going to say, I'm pretty good with parabolas, that wasn't bad. And then we're going to spend Monday and Tuesday on ellipses, and we're going to finish ellipses, and you're going to go, pretty good with ellipses, that wasn't too bad. And then we're going to spend 2 days on hyperbolas. We're going to get done, and you're going to say, that wasn't too bad. I'm pretty good with hyperbolas. And then they're all going to go together. And you're going to go, oh my God, this is so much information. So you got to keep it separate. Okay? I understand about all this stuff. See, there's good news and bad news with this. The good news is that a lot of the information in a lot of this stuff is very similar. The bad news is that a lot of information in a lot of this stuff is pretty similar. Because it's similar enough that you kind of remember it, but you don't remember whether this little twist is for ellipse or for hyperbola and stuff like that. So I'm going to try to help you keep everything as separate as possible. I'm going to try to give you the easy way to remember stuff and things like that. You're going to have to organize your notes and obviously writing everything down and stuff like that. Okay? You'll get through the end of today and you'll be like, oh, okay, I got that. And we'll do the same thing tomorrow and each day. And then when we start to put it together, and we'll try to put it together a little bit as we're going along too, to try to make it easier at the end. Okay? By the way, at the end of this chapter is a partner test rather than an individual test.
We don't pick our partners, but okay.
Guess who picks the partners?
You.
You is correct. What is a parabola?
It's a you.
Right, when I ask at this point, what is a parabola, people do like that. Okay? Or it could be like that, yeah, and that's what I get. Okay, can I tell you what a parabola actually really truly is? Okay, I'll do that. A parabola is the set of all points the same distance from a given point called the focus as from a given line called the directrix. Wow, we already got the big sigh. We're just getting started.
Can you
Oh,
talk
boy.
slower?
It's written right here.
Oh, that was not.
The set of all points, the same distance from a given point as from a given line. The given point is called the focus. The given line is called the directrix. What does this look like? Let's say that we have a parabola that looks something like that. That point right there at the bottom would be called the...
Focus.
No, come on. You know a parabola. You at least have some knowledge of a parabola. That is the vertex. Right? That is the vertex. in here, and this point will always be inside the parabola. Always, always, always inside the parabola. Will be a point, and that point is the focus. There will be a line on the outside of the parabola, on the opposite side of the vertex. And that line is called the directrix. If I draw this correctly, and I'm sure I did not because I never do, but if I have drawn this correctly, every point on the parabola is the same distance from there as it is from the line. So this distance might be d, and therefore this distance is also d. And that should be true for every point on the parabola. And that's basically the definition of a parabola. There is a line, another line. Here we have this line, but there is another line that goes right down the center, right through the focus and the vertex, and it basically splits the parabola in half, and you have actually seen this one, I believe. This is called the axis, anybody? Of symmetry is correct. The axis of symmetry, that is what splits the parabola in half. And there's one more. This is a little weird. But there is a segment that has both endpoints on the parabola and goes through the focus. And that segment, which we'll talk about more tomorrow, is called the lattice rectum. Yeah, go ahead.
Oh my God.
Go ahead. Get it out of your system.
Oh, that's I have the wrong name. Don't know, that's funny. It's really not. I know.
I know, but everybody laughs and everybody chuckles, so that's fine.
Let me succumb to my 5-year-old needs.
Okay. Focus has kind of gotten much smaller. Okay. So, you've dealt with parabolas like this before, correct? Sure. Have you dealt with a parabola that looks anything besides like that? Upside down. So you have dealt, there we go. You have dealt with a parabola that looks like that. Yes? Okay. But you have not, I don't believe, dealt with parabolas that look like that. Or like that. Until now.
I think I remember this from somewhere. I just don't know where.
Okay. Which direction would you say that this parabola opens? Up, and this parabola opens
Down.
Down, and this one opens
Right.
Right, and this one opens
Left.
Left. Okay, good. We're all on the same page there. The parabolas that you have dealt with in the past, in other words, the ones that open up or down, okay, always had an equation that was something like, y equals x squared or something like that. You know, so this could have been like y equals x squared, and this would have been y equals negative x squared and stuff like that. Okay. Well, parabolas are going to have a standard form. Okay? But because these parabolas open vertically, and these parabolas open horizontally, there are actually going to be two different equations. And it's going to be that way for the three conic sections, not including a circle. Circle just has one. There's no such thing as a vertical circle or a horizontal circle, right? But everything else, there will be verticals and horizontals. And so for parabolas, ellipses, and hyperbolas, we're going to have two formulas each time. Right? So here's our first formula. Make sure I'm doing it the same way. It's interesting, with parabolas more than anything else, I have seen more different formulas, the same thing but written in different ways in my years with different books. So I want to make sure that I'm saying the right thing. Y minus k squared equals 4p times x minus h. That's one version of the formula, or that's one of the formulas. And then the other one would be x minus h squared equals 4p times y minus k.
Does this go into the unsquared term?
That's what's coming up in a moment.
Okay, I'm trying to know.
Now, in parabolas and ellipses and hyperbolas, one of the most important things is going to be which direction does it open? Or which direction is it? Is this a vertical ellipse or a horizontal ellipse? Is this a vertical parabola or a horizontal parabola? Okay, and things like that. So, this is going to be one of those really important things that you need to keep track of. And I'm going to tell you how I remember it and how I would suggest that you remember it. A lot of you are going to try to come up with another way. I think that's a really bad idea. Because what I'm going to try to do is give you something that works for everyone, and I'm staying consistent. So I'm going to tell you this is which direction it opens. Okay? Whether it opens vertically or horizontally. And I'm going to tell you how to remember that for a parabola, and then on Monday I'll tell you how to do it for an ellipse, and on Wednesday I'll tell you how to do it for a hyperbola. Okay? I would not mess around with this. So, the thing that determines whether it's vertical or horizontal in a parabola is the unsquared term. So look for the unsquared term. Don't look for which term is squared and figure it out from there. Look for the unsquared term. It's easier and it stays consistent with what we're going to do as time goes on. So, in this first one, and when I say the unsquared term, we're talking about x or y. In the first one, which is the unsquared term, x or y? X, right? Y is being squared, x is not. So x is the unsquared term.